All right, so in the last lesson, we set up our new AR enabled app and we looked at some of the differences between AR world tracking session configuration and AR session configuration. So now I'm going to keep this configuration as the world tracking one so I can show you all the awesome things that ARKit can do. Otherwise, it'll be pretty limited and the tutorial won't be as fun. So make sure that we switch back to this particular configuration and make sure that the session is running that configuration. So we haven't actually written a lot of code up to this point. We've just been using the template code that Apple has pretty much provided us. So the first thing that we're going to do is we're actually going to comment out Apple's code. So these two lines where we're creating a scene from their ship scene and then putting that scene into our scene view. So I'm just going to command / to comment that out. And we're going to create our very own 3D AR object. And the object that we're going to create in this lesson is a cube. So let cube equals scn box, and this provides a 6-sided object whose faces are all rectangles, which is basically a really elaborate way of saying that you're creating a box. So it doesn't have to be a cube, but in our case we are going to create a cube because our width and height are going to be the same. So scn box, and then we're going to use the provided overload, which is this one, where we can specify a width, a height, a length, and also the chamfer radius. So the chamfer radius is basically how rounded you want the corners of your box to be, and we'll set that as well so you can see what it looks like. So hit enter, and we are going to say a cube of 0.1. So remember the units in here are meters. So go easy on the size here, otherwise you might end up inside the object and you won't actually be able to see it. So I'm going to say maybe just 10 centimeters, so 0.1, 0.1 and 0.1, and it's going to be a cube, so it's going to be equal on all 3 dimensions. And then I'm going to actually give it a chamfer radius, and I'm going to give it a 0.01. And you can mess around with this until you create an object that you're satisfied with, but to my eyes that looked quite good when I tested it. Alright, so by default, any object that you create in SceneKit has this white matte texture to it. So our cube will be a white cube, and you can try it out later on, but it kind of looks like those objects that you get when you go to still life drawing classes. It's pretty boring, so let's go and jazz it up a bit. So I'm going to create a material. I'm going to call it material, and it's going to be created using scn material. So all of these methods are from the SceneKit framework, so that's why they're all preceded with scn or scene. So scene box, scene material, and then we're going to change one of the material's properties. And the property that we want is the diffuse property. So as we said earlier, this is basically the base material of that object. So material.diffuse.contents, and we're just going to set it to a UI color, maybe a red color, since we're making a dice, right? And then all we have to do is just add that material to the cube. So cube.materials, and you can see that this is actually looking for a array of SCN materials, because you can actually assign multiple materials to the same object. So you can change the diffuse, or you can change the shininess of it, or the metallicness of it, or the texture, a whole bunch of things. But right now, all I want is just to give our cube a nice red color. So it's pretty simple. So I'm going to make an array that only contains our material that we just created. So there's our cube created and styled. The next thing that we're going to do is we're going to create our first node. So scene nodes are basically points in 3D space. So when you first create it, it's not really anything, but you can assign it a position in 3D space, and you can give it an object, so what it should display at that position in 3D space. So let's go ahead and create our node. Let's call it node. And as you expect, it's under scn node. So it's going to be a new object created from scn node, and then we're going to give it a position. So you can see that this position is of type scn vector 3, so scene vector 3, and this is basically a 3-dimensional vector. So it has a x position, which is the translation along the x-axis, so left and right. It has a y-axis, so up or down, and it has a z-axis, which is towards or away from you. So we can create that using scn vector 3, and we want to use the overload that takes 3 floats, so x, y, and z as floats, and I'm going to give it some vectors. So on the horizontal axis, I'm just going to say 0, keep it in the center. On the y-axis, let's say 0.1 to raise it up a little bit by about 10 centimeters. And then on the z-axis, let's say minus 0.5. So you might be wondering, why am I using minus? Well, for all the other axes, it's pretty intuitive. Positive x is towards the right, negative x is towards the left, positive y is going up, negative y is going down, but for the z, positive is coming towards you and negative is going away from you. We tend to think of positive as forwards, but in this case it's actually flipped around. So just make a note of that. All right, cool. So our node now has a position. Now we just need to give it a geometry, and you guessed it, that geometry is going to be our lovely cube that we created earlier on. So node dot geometry is going to be equal to cube. All right, cool. All right, so let's just recap. First, we created this geometry called cube, and we used a method from the SceneKit framework that allows us to create boxes pretty easily, called SceneBox. And we gave it a width of 10 centimeters, height 10 centimeters, length 10 centimeters, and we made the corner slightly rounded. And then we created a material that is basically just the color red. And then we assigned that material to the cube materials array. And it currently only has one material in its array, but that's fine. That's good enough for now. And then we created this node, which is a point in 3D space, and then we gave it a position, which is centered on the x-axis, slightly elevated, and slightly away from us. And then we assigned that node an object to display, or a geometry, and that was, of course, our cube that we created earlier on. All right, so now all that remains is actually putting our node into our scene view. So let's tap into sceneview.scene.rootNode.addChildNode, and the node that we want to add is, of course, this node that we created. So let's have a look at this line of code. So here we are adding a child node to our root node in our 3D scene. So for any given scene, you could have a whole bunch of child nodes. So for example, you could display a box as well as a sphere. So for example, you could have spaceship and alien invaders. And you want to add those in to your scene as child nodes. So if you actually have a look in the ship scene, you can see that this is the current root node, ship. And if I expand that, you can see that ship has a child node called ship mesh. And if I select it, that actually refers to this ship that you see on scene. And then that ship mesh itself has a child node called emitter. And this is the node that is going to be used to display maybe particle effects. So for example, smoke coming out of the bag or fire coming out of the bag. And this is a child node to the ship, to the main root node of the scene. So I hope that makes a bit of sense, and but all we need to do is give our app a spin and run it on the device, and you'll see what our code has magically achieved. So let's do that. All right, so there's our lovely box, and you might have noticed that one thing is a little bit odd. The cube looks a little bit flat, right? Doesn't look all that 3D. And the reason is because of light. In order to see something as 3D, we need to see highlights and shadows. If you've ever seen crazy makeup contouring tutorials, then you'll know exactly what I'm talking about. So all we have to do is just add some light. And we can do that in one sentence in scene view. So scene view dot auto enable default lighting. Set it to be true. And now let's run our app again and let there be light.